Hi everyone. In this video, we are going to revise when we say the given differential equation is exact and how to solve. Get it? And with the help of this example, we will discuss how to solve exact differential equation. See, if you have differential equation in this format, m dx plus n dy is equal to 0. Okay, you can see this example also. It is also in same format. Multiple of dx, which is m, and multiple of dy, which is n. So if you have differential equation like this, m and n both are functions of x and y. If derivative of m with respect to y, getting, so it's a partial derivative. Derivative of m with respect to y is same as derivative of n with respect to x, then we say the differential equation is exact. So in this case also, in this given example also, we will check whether it is exact or not. Okay, so let me note down our m and n. Okay, so let me write, we have, what is our m? M is a multiple of dx, which is y square e raised to xy square plus 4x cube. And what is our n? N is a multiple of dy. So here multiple of dy is this one. So this is our n. So n is equal to 2xy e raised to xy square minus 3y square. So this is our n. Getting? So m and n I have noted down. So after that, we have to check the partial derivative of m with respect to y is same as partial derivative of n with respect to x. So let us find both partial derivatives and we will check whether both of them are equal or not. So let us find derivative of m with respect to y. What is my m? My m is, let me note down here, y square e raised to xy square plus 4x cube. Okay, so it is looking complicated, but don't worry, we will solve it, right? You know that if we have addition, we take the separate derivatives. So I will take the separate derivatives. So derivative of y square e raised to xy square plus derivative of 4x cube. So after that, what we do, if you have any constants, we take them outside. So but see, here we are differentiating with respect to y. So y square is a variable, and in exponential function also y square is involved. That means there is no any simply constant, you cannot take anything outside. But see, in this case, 4 is a constant. We are differentiating with respect to y. It means x cube is also constant. So both of them are constant and derivative of constant is 0. It means this derivative is 0. It's quite simple. Now we have to work on this part. As you can see, there are two terms. The first one is y square, and the second is exponential function. So if you have product of two functions, we go for u into v formula. That is derivative of u into v, u into derivative of v plus v into derivative of u. Getting? So this formula I am going to use to find its derivative. So this is u and this is v, first into derivative of second. So let me write y square as it is, derivative of e raised to xy square plus e raised to xy square as it is, just like this. Now v as it is, and derivative of the first term. Okay, sometimes we say the first into derivative of second plus second into derivative of first. So we got the derivative plus 4x cube. As I told you earlier, this is constant since we are differentiating with respect to y, and derivative of constant is 0. Now we have to focus on just this part only. So y square. Okay, so what is derivative of exponential function? You know that derivative of e raised to x is always same. Exponential function derivative remains same. So that's why its derivative will be e raised to xy square. But see, there is power looking complicated. So again we need to differentiate it with respect to y. So I am using chain rule and I am again differentiating the power xy square. Plus, let us move further. Here e raised to xy square as it is. Now we have to find the derivative of y square. So we know the formula. Derivative of x raised to n is n x raised to n minus 1. So when you take the derivative, if you have any power, we write it first, we reduce it by 1. So here the power is 2. So 2 as it is, and we reduce the power by 1. So 2y raised to 1. So I got the derivative, right? Okay. So this is equal to y square e raised to xy square. Okay. So now we have to differentiate. But see, x is constant since we are differentiating with respect to y. So I will take x outside. So inside the bracket, simply we will have y square. And this is 2y e raised to xy square. Okay. So derivative of y square is 2y. We have seen here derivative of y square is 2y. So I should write 2y here. So y square e raised to xy square into x into 2y plus 2y e raised to xy square. Okay, I need some more space to write. Let us use this space. Okay. So this is equal to, let us take the product and let us write in simple way. So 2y into this y square, you will get y cube, and this x is also there. So 2xy cube e raised to xy square plus on this side we have 2y e raised to xy square. So finally we got the derivative of m with respect to y. Okay, so we got its derivative of m with respect to y. Now we have to find derivative of n with respect to x. Okay, so let me remove this part. We'll have some more space to write. Okay, so now derivative of n with respect to x. What is my n? This is my n. So as you can see, there are two terms, okay, and if there is a minus sign between them, so if we take derivative, if there is addition or subtraction, we take separate derivatives. Here also I will take separate derivatives. Derivative of 2xy e raised to xy square minus derivative of 3y square. So if we have any constants, we always take outside first. Okay, so the problem will be very simple. Then if you take constants outside, 2 is constant, you can take it outside. Y is also constant since we are differentiating with respect to x, so y also will come outside. Inside the bracket we will have simply this x and e raised to xy square minus, let us talk about this. Will you tell me what will be its derivative? We are differentiating with respect to x, so y square is constant, and we know that 3 is also constant. Derivative of constant is 0, so its derivative will be 0. So 2y, getting? So here there is a product of two functions, both are functions of x and this e raised to xy square. So here also I have to use the same rule again, derivative of u into v formula. Tell me what is derivative of u into v formula? U derivative of v plus v derivative of u, getting? First into derivative of second plus second into derivative of first. So this is u and this is v. Okay, so let us see what will be its derivative. X as it is, derivative of this e raised to xy square plus e raised to xy square as it is, derivative of x. So I use here first into derivative of second plus second into derivative of first. Now we have to find its derivative. Okay, so let me remove this part. Okay, so this is equal to 2y x. So we have to take its derivative. There is an exponential function and the derivative of exponential function remains same. So its derivative will be e raised to xy square. But see, there in a power we have some function again. So by chain rule we supposed to take its derivative again. So its derivative I supposed to take again. So it is xy square plus e raised to e raised to what? Xy square, and the derivative of x will be 1. We are differentiating x with respect to x, derivative will be 1. So this is equal to 2y x e raised to xy square into, so here y square is constant, it will come outside, so y square will come outside. Inside the bracket simply we have x plus this is e raised to xy square. Okay, so we are very close to that final step. Okay, 2y, this Okay, x into y square, I should write xy square e raised to xy square. Tell me what is derivative of x with respect to x? 1. Derivative of x with respect to x is 1 plus e raised to xy square. So now what will I do? I will take the product. Okay, I will solve this one. 2y into first term plus 2y into second term. So what will happen? So 2x is there, y into y square, y cube, e raised to xy square plus this 2y into this e raised to xy square. So in this way we calculated both partial derivatives. Now we have to check whether both of them are same or not. Let us see. First term 2xy cube e raised to xy square, 2xy cube e raised to xy square. The second term 2y e raised to xy square, 2y e raised to xy square. Getting that means both derivatives are same. The given differential equation is exact. So let me clearly mention, therefore dabba m by dabba y is equal to dabba n by dabba x. It means given differential equation is exact. Okay, so the given differential equation is exact. So now we have proved it is exact differential equation. Now the question is how to solve. Okay, just make a screenshot of it, then we will move further. See, there is a fixed formula, okay, to calculate solution, to find a solution of exact differential equation. That formula is integration m treating y constant, okay, dx plus integration terms in n free from x dy is equal to c. So this is the solution. Okay, if you have exact differential equation, you can use this formula to calculate its solution. So actually there are two integrals, getting the first integral involving m, the second integration involving n. So what will I do? I will solve these two integrations separately. We will add them and we will get the answer. Okay, so what is the first integration? Let me write here. So consider integration m treating y constant with respect to x. Okay, so that means we have to integrate m. What is my m? This first bracket is my m. So y square e raised to xy square plus 4x cube dx. So this is my m. So now I'm going to integrate. So in bracket what we have mentioned, treating y constant. That means if you have any y or any function of y, you have to consider it as a constant. Addition is there. I can take separate integration y square e raised to xy square dx plus integration 4x cube dx. Always I take constants outside. What is a constant here? Y square. Since I have already mentioned treating y constant, so y square will come outside, e raised to xy square dx. What is a constant here? 4 is a constant. Inside the integration we will have x cube dx. Now the question is how to solve this integration. No need to worry, this y square is a constant, getting, so I can apply this formula. Integration e raised to x is e raised to x upon a. If you have any constant as a multiple of x, you can write in denominator. I will do the same. So y square into integration will be e raised to xy square. Y square is a constant, so I am writing in denominator plus 4. How to find integration of x cube? We have this formula. Integration x raised to n is x raised to n plus 1 upon n plus 1. Whatever the power we have, we increase it by 1, and the same we write in denominator. So power is 3. I will increase it by 1. So 4 divided by 4. So we will get benefit of it. That is 4 we can easily cancel. Here y square we can cancel. So what is the remaining part? This is e raised to xy square, and here x raised to 4. Okay, so I got the value of first integration, which is this one. Now I need to focus on the second integration. Okay, so let me write here. The second is now integration terms in n free from x dy. That means we want terms of n which are does not contain x. Okay, so you can see this is our n. There are two terms, first term and second term. In first term there is x, so that's why I cannot consider the first term here. In second term there is no any x, that means the second term is free from x, so I will consider the second term only, which is minus 3y square dy. So that minus 3 is constant, will come outside, we will have y square dy. What is the integration of y square? I can apply the same formula again. If you have any power x raised to n, we write x raised to n plus 1 upon n plus 1. Whatever the power we write, we increase it by 1, and the same thing we write in denominator. Minus 3, so integration will be y cube by 3. So 3 will get cancelled, right? 3 will get cancelled, and the answer will be minus y cube. So I got the values of both integrations, so I will write the solution is, then the solution is simply I need to add value of these two integrations. Okay, so let me remove this part. So I will get here, solution is e raised to xy square. Okay, if you want I will write it again, that part. So that is integration m treating y constant dx plus integration terms in n free from x dy is equal to c. So the value of first integration is e raised to xy square plus x raised to 4 plus the value of second integration is this minus y cube. Minus is there, so minus y cube is equal to c. So this is required answer. Okay, so in this way we solve this exact differential equation. Okay, so make a screenshot of it and then we will stop. Thank you. See you in next video.